Evaluation of fuzzy reasoning tool using a genetic algorithm. Now, fuzzy sets are sets with imprecise boundary. Now, there are several applications of the principle of fuzzy sets, and fuzzy reasoning tool is one of them. Now, the purpose of developing this fuzzy reasoning tool is to establish the input output relationship of a particular the process. Now, to establish this input output relationship, the first thing we will have to do is for this fuzzy reasoning tool. So, we will have to design and develop a suitable knowledge base. Now, knowledge base consists of the database and the rule base. Now, to define this database and rule base, I am just going to take one practical example. Now, before that, let me tell that our aim is to develop this genetic fuzzy system. Now, here the purpose of using genetic algorithm is to design or evolve a suitable knowledge base for this particular the fuzzy reasoning tool. Now, to define the concept of this database and the rule base, now I am just going to take the example, a practical example. Now, supposing that say I have got a process having say 2 inputs and 1 output, and this particular problem is related to one physical scenario. Now, let me try to explain in brief that particular physical scenario. Now, supposing that I will have to solve a dynamic motion planning problem of a robot, dynamic motion planning problem of a robot. Now, here the purpose is to find out a collision free time optimal path for the point robot. So, for simplicity, let me assume that this is the scenario of a particular robot, mobile robot, and for simplicity, let me consider that this is the point robot denoted by R. Now, supposing that, so this indicates its starting position and the goal is here. Now, aim is starting from here to reach this particular the goal. Now, supposing that there is no such obstacles here. So, very easily it will start from here and it is going to reach this particular the goal. But fortunately or unfortunately, supposing that there are a few obstacles, like say I have got obstacles like say here I have got a point this type of circular obstacle, there is another obstacle here, there is another obstacle here. So, this particular obstacle is moving in this direction, this is moving in this particular direction, this is moving in this particular the direction. Now, if this is the situation, now this particular path will not remain as a feasible one, and I will have to find out a collision free path, and to decide the collision free path I can take the help of one fuzzy reasoning tool, the fuzzy reasoning tool. Now, let us see how to design and develop one fuzzy reasoning tool to solve this particular the problem. Now, out of these 3 obstacles, so this is obstacle 1, obstacle 2 and obstacle 3, and this is the starting position of this particular robot. Now, from here it will try to look towards the goal, and this particular obstacle will be treated as the most critical obstacle. Now, to take care of that and to avoid collision with this particular the most critical obstacle. So, what we do is we try to find out 2 inputs for the fuzzy reasoning tool, and there will be one output, that is nothing but the deviation angle. Now, let us see how to find out that. Now, what we do is the 2 inputs is, one is the distance between the robot and the most critical obstacle. So, this particular distance is decided by this. So, this is nothing but the distance input say d. Now, similarly, we also try to find out another input, that is the angle input, that is the angle between the goal, the present position of the robot and the center of the most critical obstacle, and this particular angle is this. So, this is nothing but, say, it is denoted by A. Now, these D and A are the input. That means, if I consider if I just consider your if I just consider, so this particular thing, so this is the starting position and this is the goal, and this is the most critical obstacle, say O1. Now, here, so one input is this. So, this is the distance input and this is the angle input. Now, our aim is to find out what should be the deviation. Now, what we do is we are going to design and develop one fuzzy reasoning tool. D is one input and angle is another input, and the deviation, say this is nothing but, say O. So, this is nothing but, say O, or say O prime is the deviation. So, that particular deviation angle we will have to find out. So, this particular deviation angle is nothing but the output of this fuzzy reasoning tool. So, our aim is to design and develop this fuzzy reasoning tool, so that it can solve the dynamic motion planning problem. And to solve this dynamic motion planning problem, so the first thing is we will have to design and develop this fuzzy reasoning tool, and then we will see how to modify and how to optimize with the help of this particular the genetic algorithm. So, I am just concentrating on this particular problem, but let us try to see in more details. Now, what we will have to do is, so we will have to find out a suitable membership function distribution or suitable representation for D, that is the distance, and a suitable representation for the angle, the input angle, and of course, a suitable representation for this particular the deviation. Now, what we do is, so we try to take the help of some membership function distribution. Now, the membership function distribution I will be discussing in much more detail. Now, what I am going to do is, supposing that, so this particular distance, say unit could be, say in meter, the angle, the unit could be in degree, and this particular deviation, the input could be, unit could be in degree. Now, let us try to design some membership function distribution. Now, once again let me repeat, our aim is to define what do you mean by database and rule base of a fuzzy reasoning tool, that I am going to define. Now, for this particular distance, we are going to use a few linguistic terms. For example, say it could be very near distance, it could be near distance, the far distance, and very far distance. Similarly, this angle, it could be your the ahead angle, then ahead right, then comes ahead left and the left. So, there are 5 linguistic terms. Similarly, this particular the deviation we are going to define with the help of ahead right, then comes ahead left and left. So, there are 4 linguistic terms for distance, 5 linguistic terms for the angle input, and 5 linguistic terms for this particular the deviation. Now, so 4 multiplied by 5, there will be actually 20 rules. Now, how to design that particular database and the rule base, that I am going to discuss. Now, to design this, what you can do is, so I am just going to show the membership function distribution for this particular the distance. That means, the membership function distribution for very near, far and very far. Now, let me take this type of distribution, and for simplicity let me consider the triangular distribution. So, here this shows actually the very near distance. So, this particular triangle is nothing but the very near, then this is nothing but the near, then this is nothing but the far, and this is nothing but the very far. And here actually we will have to put, so this is the distance, and definitely there will be some unit, and let me put some numerical value. So, might be 0.2 meter, then 5.2 meter, then 10.2 meter, 15.2 meter. And here we have got the membership function value mu, and its range is 0.0 to 1.0. Now, here a particular distance. So, if I concentrate on a particular numerical value for the distance, say I am here. Now, if I am here, so this particular distance, so might be this is say 6.5 meter. So, 6.5 meter can be called near with this much of membership function value, and it can also be called far with this much of membership function value. That means, the same distance can be called near with one membership function value, it can also be called far with another membership function value. So, this particular the definition or the description of the distance is not crisp, it is fuzzy in nature. This is the concept of the fuzzy sets. Now, here now I will have to design the membership function distribution for this angle and this deviation. For simplicity, let me assume that they are having the similar type of membership function distribution, and we can also consider the different types of membership function distribution also. Now, here actually what we do is, so we try to draw the membership function distribution for this ahead. So, this could be the ahead, then ahead right. So, this could be the ahead right, and this is the right. Now, this is ahead left and this is the left. So, this is left, this is ahead left, this is ahead right and right, and numerical value. So, this is the angle A and this particular deviation, I am just using the same membership function distribution. Now, here, so the unit is actually the degree. So, let me put 0 degree here, that is ahead, then ahead right, let me put plus 45, that means this side, and like clockwise 45, say plus 90, similarly minus 45 and minus 90. So, these numerical values we can assign. Now, once you have assigned the numerical values for this particular angle input and this particular deviation and the distance. So, these information whatever I am just putting it here is known as the database of these particular the inputs and the output of this process. This is what we mean by the database. And once you have got this particular database, now we are in a position to design the rules. For example, the first rule could be, if distance is very near and angle is ahead left, then the deviation is nothing but ahead. So, this is the rule. So, let me just write here a particular rule. If the distance d is very near and the angle A is say ahead left, then the output, that is the deviation, is nothing but ahead. So, this is a particular rule. This is a rule. Similarly, I can design 4 multiplied by 5, 20 rules in the rule base, and this is what I mean by the rule base of a fuzzy reasoning tool. So, I hope the idea behind this particular the database and the rule base is clear. Now, I am in a position to proceed further to discuss the working principle of this. So, let us try to concentrate here. So, our aim is to design and develop the knowledge base, which is nothing but a combination of database and rule base, which I have already discussed. Now, this particular database and rule base can be actually optimized with the help of a genetic algorithm, but genetic algorithm is computationally expensive. So, this particular training has to be implemented offline, and once it is trained, now we can use for some test scenarios online. That means, I can pass say one set of inputs to the GA optimized or the GA tuned or the GA evolved fuzzy reasoning tool or fuzzy logic controller, and for this set of inputs. So, I will be getting this particular output, and of course, this is online, because within a fraction of second for a set of inputs I will be getting this particular the output. but the training has to be provided offline, because GA is computationally expansive and this particular training is provided with the help of some predetermined or pre-collected training scenarios. Now, let us see how to proceed further. Now, if you see the literature, now this genetic fuzzy system actually has been defined in different ways. That means, we can optimize the database only. Now, how to optimize this particular the database? Now, if we take the same example of this particular the triangular membership function distribution. Now, for example, say this is the very near, this is the near distance and this is the far and this is very far. Now, if you see, so this is nothing but the half base width of this particular triangle, say d 1, and what you can do is, so during the optimization, so I can find out what should be the optimized value for this particular d 1. So, d 1 is going to vary in a range and it will try to find out what should be the optimal value. So, if d 1 is more, so this will be some sort of flatter distribution for the triangle, and if d 1 is small, then it will be steeper. So, d 1 is large, you will be getting the flatter distribution, and if d 1 is small, so you will be getting that particular the steepest distribution for this particular triangle. Similarly, we can also optimize the rule base. Now, if you take the same example, so out of these 4 multiplied by 5 rules which are present in the rule base, all the rules may not be equally good. So, using GA we can find out what should be the optimal rules, and that is actually what we mean by optimization of rule base. Now, the performance of this fuzzy reasoning tool depends on both database as well as rule base, and that is why we can also optimize the database and rule base, the both the things either in stages or in or simultaneously. So, using any one of these, we can find out what should be the optimal the knowledge base of this particular the fuzzy reasoning tool. Now, before I proceed further, so let me tell that we use different types of membership function distribution. Now, as I told, the triangular membership function distribution we use very frequently, because it is computationally efficient and it is faster. So, this is actually the linear distribution, and this is nothing but the triangular membership function distribution. Now, similarly, there are some other membership function distribution, like we use some sort of trapezoidal membership function distribution. So, this type of trapezoidal membership function distribution also we use. Next, we use some sort of Gaussian distribution. For example, the Gaussian distribution could be something like this, and this particular Gaussian distribution is decided by the mean and the standard deviation value. So, this is nothing but the Gaussian distribution of the membership function distribution, and sometimes we use the bell shaped curve, like for example, it will be something like this. So, it is almost similar to this. So, this is nothing but the bell shaped curve, and sometimes we use some sort of sigmoidal membership function distribution, and it is looking like this. So, the sigmoidal membership function distribution, so this type of distribution. So, mu equals to 0.0 and this is 1.0. So, everywhere here actually mu equals to 0.0, this corresponds to 1.0. Similarly, this corresponds to 0.0 and this is 1.0. Similarly, here it is 0.0 and mu equals to 1.0, 0.0 and here it is 1.0. So, this is the way actually we can design the different types of membership function distribution, and we just take a particular the distribution, and if required we can further optimize the shape and size of this particular the membership function distribution. For example, say if I want to optimize the membership function distribution which is nothing but Gaussian. So, what we can do is we can keep this m, that is the mean, and the standard deviation sigma as the design variables inside the GA string, and GA is going to supply what should be the suitable value for this particular m and sigma. Similarly, the different other types of membership function distribution we can optimize with the help of this genetic algorithm. Now, if this is the situation, now we are in a position to design the fuzzy reasoning tool, and let us see how to evolve or how to design the optimized fuzzy reasoning tool. Now, here I am just going to discuss the working principle, like how to evolve a fuzzy reasoning tool with the help of a genetic algorithm. So, that particular problem I am just going to discuss with the help of a numerical example. Now, let me state the numerical example first. A binary coded GA is used to obtain optimal database and rule base, optimal database and rule base of a fuzzy reasoning tool. So, we know the meaning of database and rule base. There are two inputs I 1 and I 2 and one output, that is O of the process. So, here if you see, so these are the membership function distribution for the two inputs I 1 and I 2 and for the output, and for simplicity we have considered the triangular membership function distribution. Now, for this particular the first input, there are four linguistic terms like low, medium, high and very high. Similarly, for I 2 we have got low, medium, high and very high, and for this output we have got low, medium, high and very high. Now, this B 1 is going to decide like your the size of this particular the triangular membership function distribution. So, B 1 is nothing but the half base width of this particular isosceles triangle or the base width of this particular right angle triangle. So, this B 1 is nothing but the design variable for this I 1, and here similarly B 2 is the design variable for I 2 and B 3 is the design variable for this particular output O. And for simplicity we have considered the symmetrical membership function distribution, and as I told that for simplicity we have considered the triangular membership function distribution, and mu is nothing but the membership function distribution which will vary from 0 to 1. Now, here we can see for I 1 we have put some numerical values like 6, 9, 12 and 15, and as I told we have considered the symmetrical membership function distribution. Similarly, for I 2 the numerical values are 20, 30, 40 and 50, and for this particular output the numerical values are 2, 3, 4 and 5. They are having their respective units and respective ranges. Now, to proceed further, so what we can do is, now as there are 4 inputs for this particular I 1 and 4 inputs for this particular 4 linguistic terms for I 1 and 4 linguistic term for this particular I 2. So, we have got 4 multiplied by 4, there are 14 rules, and these rules are manually designed rules. So, based on the experience of the user can define this particular the rule base. Now, for example, the first rule will be something like this. So, this is the output of the first rule. The first rule is as follows: if I 1 is low, if I 1 is low and I 2 is low, if I 1 is low, I 2 is low, so output is low, then the output O is low. So, this is actually the first rule. Now, similarly, there will be 16 such rules, and these are all manually constructed rules. So, it may not be optimal, it may not be good, some of the rules could be good, but all the rules may not be equally good. So, GA will try to find out what should be the optimal rule base, like which one out of these 16s are really good. Now, let us see how to do it. Now, a binary coded GA is used to optimize the database and as well as the rule base of the fuzzy reasoning tool with the help of a set of training cases. So, here there are a large number of training cases, and the training cases are nothing but the known input output relationship. For example, the first your the training case is nothing but this: if I1 is 10.0 and I2 is 28.0, so output is 3.5. Similarly, we have got capital T number of the training scenarios, and these are pre-collected and the known values. Now, here one thing I just want to mention. Now, unlike the neural networks, like here the inputs are actually sent in the real scale, not in normalized scale. If you remember, in neural network we used to send the inputs in normalized scale, but in fuzzy reasoning tool we can supply the inputs, that is I1 and I2 in the real scale. You need not go for the normalized scale. The reason is very simple, because there will be fuzzification, and during the fuzzification actually there will be normalization. So, we need not send these particular inputs in the normalized form. So, this is the difference between the neural network and fuzzy reasoning tool. An initial population of the binary coded GA is created at random. So, this shows the initial population of this particular the binary coded GA, and the population size is capital N, and here actually this particular GA string that is created at random. Now, what should be the length of this particular the GA string? Now, if we remember, we have got 3 actually the real variables like B1, B2 and B3, and they are going to indicate what should be the half base width of the triangular membership function distribution representing I1, I2 and the output O. And let me assume that we are assigning 5 bits each to represent. So, 5 bits, 5 bits and 5 bits. That means, your the first 5 bits is going to represent your this particular the B1, the next 5 bits is going to represent the B2, and the next 5 bits are going to represent B3. So, we have used 15 bits here, 5 plus 5 plus 5, and there are a few other bits here, and in fact, we are using 16 bits here just to represent the 16 rules which I have already discussed. So, these 16 manually constructed rules are represented by, so these particular your the 16 bits. Now, a particular bit, if it is 1, then it indicates that that particular rule is present, and if it is 0, that means that rule is absent. That means, so here we have got a 1 here, that means the first combination, that the first rule of the manually constructed rule base is present, but the second, third, fourth are absent and the fifth is present, and so on. So, out of these 16 rules, only a few will be present and others will be absent, corresponding to this particular the GA string. Similarly, we have got the other the GA string. Now, here once you have got this particular GA string, now we will have to state the range for the variables. Now, here we can see whatever I mentioned, the same thing I have written it here. The starting from the leftmost bit position, 5 bits are assigned to represent each of the B values like B1, B2 and B3, and the next 16 bits represent the rule base of the fuzzy reasoning tool. And our aim is to determine the deviation in prediction for the first training case by using the first GA string, and the B values are assumed to vary within these particular ranges, like B1 is lying between 2 and 4, then comes. So, B1 is lying between the 2 and 4, and then B2 is lying between 55 and 15.0, and B3 is lying between 0.5 and 1.5. Now, here, so this is the range for this particular the variables. Now, we are going to solve it. Thank you.